So what is variable acceleration? What is the other name for variable? Students who are present in the class, that is yesterday's class. It is called as non-uniform acceleration, right? Variable
Yes,
acceleration
sir.
is otherwise called as non-uniform acceleration. Okay, and to solve problems, okay, so to solve problems concerning variable acceleration, that is that if an object or a body, okay, if an object or a body moving with variable acceleration, okay, so how do we calculate it? Through simple mathematical relations, right? Simple mathematical relations. Okay, so what are they? There were 4 cases, no? Can you remember those 4 cases? So what is case 1? Anybody? What is case 1? So is Nitish were present yesterday? Was Nitish present for yesterday's class? So what about Jayashri and Soumya? Do we have Jayesh?
Sir,
Yeah. What is case 1?
displacement,
Yeah.
displacement is a function of time, sir.
Very good. Displacement is a function of time. Very good. Displacement is a function of time. That is S is equal to F of t. So if displacement is a function of time, then how do you calculate velocity?
By differentiation, sir.
Yes, by differentiating. Yes, differentiating the displacement. Okay, with respect to time. Then how do you get acceleration? Differentiating velocity, right? Okay, so this
Yes,
is,
sir.
yeah, so this is what we have seen. Very good. And what is case 2?
Acceleration is a function of time.
Very good. Acceleration is a function of time. Very good. So that is a is equal to f of t. Okay, that is if a given equation of motion, if a given equation of motion is the acceleration is a function of time, that is a is equal to f of t, then by integration, right? Then by integration we get what?
Yes, sir.
Yeah, by integration we get what? If I integrate acceleration, what do I get? Velocity, right?
Yes,
Then
sir.
by, yeah, then by further integration, what will I get? If I integrate velocity, what will I get? Displacement. Okay. So, so you guys remember this? What we have learned in yesterday's class. So, what about case 3? What is case 3?
Ac- Acceleration is a function of velocity, sir.
Very good. Acceleration is a function of velocity. Sorry, is a function of velocity. That is a is equal to f of v. Then what you will do? If a is equal to f of v, that is acceleration as a function of velocity. If a given equation of motion is acceleration is a function of velocity, then what you will do?
So V equal to ds by dt, sir.
Very good. Acceleration a is equal to what? V dot dv by ds.
dv by dt.
dv by ds. What is v here? ds by dt. Okay. Dot dv by ds. So if this is cancelled, we get acceleration a is equal to dv by dt. So whenever we encounter a equation of motion as acceleration is a function of velocity, we use this formula, that is A is equal to V dot dV by ds. Okay, just hold on a moment. Yes, sorry about that, ma. Okay, so yes. Okay, so what is case 4? What is case 4? Acceleration, yes, is a function of distance. Okay, that is A is equal to, okay, f of s. If a given equation of motion is acceleration as a function of distance, then what we will do, we'll write acceleration as the same that what we did in the velocity part, that is velocity into ds by, sorry, velocity to dv by ds. Okay, so always remember this, dv by ds. Okay, so yesterday we just worked out an example, that is a sum here, that is NEET 2016. So you guys clear with the sum or not? So are you all clear with that sum or not yesterday? Did you have any doubts? Did you have any doubts?
No,
So yesterday you are clear with this sum. Okay. So we'll proceed to the next one. Okay. Yeah. Here, see, this is 2015. This is also actually AAPMT. Okay. Now NEET. You can write either things, AAPMT or NEET. Okay. 2015 sum. Okay. So they have said that a particle of unit mass, undergoes one-dimensional motion, okay, such that its velocity varies, okay, according to, okay, the velocity varies according to, they have given an equation where b and n are constants, okay, and x is the position of the particle. X is the position of the particle, okay. They are asking the acceleration of the particle as d function of x is given by. So read this question by yourself, okay. I'll give you a minute, okay. And if you understand this question, or what do you understand this from this question, just let me know, okay. So you just read out this question. I'll give you a minute, okay. And what do you understand from this question, just let me know. Even if the question is, not even is uh, not even a single line is clear, that is not a problem. Just tell me that also, okay? Because it's going to be an interactive session, okay? Because we are solving sums, okay? So what do you get from this question? Anyone? What do you understand from this question? They're saying a particle of unit mass. First, you have to neglect this. Am I right or not? Okay, we have to neglect this because we don't have to worry about mass. Why? Because we are dealing with motions along a straight line. So while calculating motion along a straight line, we don't need to worry about mass. Okay, we don't need to worry about the particle's mass. Okay, that is there. And they are saying it undergoes straight line motion, that is one dimensional motion, such that its velocity varies according to they have given v of x is equal to v of x, okay, minus 2 power n, and they are given the velocity as a equation. They have said that b and n are constants, okay, b and n are constants. X is the position of the particle. They are saying x is the position of the particle, okay. And what they are saying here, they are given the four options. These are the answers, okay. They are saying the acceleration of the particle as d function of x is given by, just read this line and just think to yourself, the acceleration of the particle as d, okay, function of x is given by. What do you mean by this particle? That is, what do you mean by this sentence?
So differentiate the V of X, sir.
No, what they are asking, that's what I'm saying, what they are asking in this question, just read out this sentence, the acceleration of the particle as d function of x is given by. What do you mean by that? What can we make out of that sentence? The acceleration of the particle as d function of x, what does it mean? When we say x, okay, how can we specify x? What names we can give for x? We have seen in the earlier classes while we are while we are handling problems,
Displacement, sir.
we can say x is a displacement, okay. Then what else?
Position.
Position, very good. What else? We can say x as displacement, position, and also what? Another one thing is there, no? We can say x as a displacement, okay. We can say x as a position, okay. Another thing, distance, right?
Yes, sir.
X can be used in the place of displacement, position, and distance, okay. So tell me, they are asking, they are saying the acceleration of the particle as the function of x is given by. So how can we place this x in the place of x? What can we substitute, and we can you can discover what kind of problem is this. In the place of x, substitute displacement, okay. So what they are asking, the acceleration of the particle as function of displacement, okay, it cannot be done, okay. We didn't see any cases like that. The acceleration of the particle as function of position, did we see any cases like that? No.
No,
No.
sir.
Yeah. Then the last one, the acceleration of the particle as function of, in the place of x, if I say distance, the acceleration of the particle as a function of distance, did we see any cases in that?
Yes, sir.
Yes, very good. Which case is that?
Case 4.
Case 4, acceleration, that is the given equation is a acceleration as a function of Sorry, as a function
And the
of
function of distance, sir.
distance. Very good. So this is what they are asking. The acceleration is a function of distance. So what is the formula when this comes? A is equal
V
to
dot dv,
v dot
v dot dv by ds.
ds. In the place of s, we can say x also.
Yes,
Okay,
sir.
right. So this is what they are asking. This is what they are determined here. They are given 4 options. They are asking which option is right for this acceleration. So you understand the problem?
Yes, sir.
Okay. So what we have to find out? We have to find out this acceleration. That is acceleration as a function of distance. Okay. But what do you have as equation? You have velocity as a function of distance. Velocity as a function of what? Sorry.
Distance.
Sorry. They are given velocity here. Okay. They are given velocity as a function of x. That is what? Distance, right? Function of distance. That is x. Okay. So now you know velocity. V of x is equal to b of x power minus 2n. So find out, in order to find acceleration as a function of x or distance, find out dv by dx first. So what is dv by dx? You know what is v?
Minus.
D by dx of b power x power minus
Yes, sir.
2n. Yes. So what happens? This minus b is a constant, so it cannot be differentiated.
Yes, sir.
Yeah. So
Minus
minus
2,
2n. Yeah.
2n beta
Beta. Yes. Bx.
x power
Yeah.
minus 2n minus 1, sir.
Very good. Minus 2n minus 1. This is nothing but dv by
dv by
dx.
dx.
Okay. So you have found out dv by dx. What is v? V is given in the question itself. V is given in the question itself. You understand? So
Yes, sir.
substitute that. A is equal to what? V dot dv by dx. Substitute this v here. Okay. In the place of velocity. That is b x power minus 2n. Okay. Into dv by dx is what? The one we have found out here. Minus 2n bx power minus 2n minus 1. Yeah. Now multiply it. Here is b, here is b. So you'll have what? Minus 2n will be there. So minus 2n. B into b is b squared. So x power 2n into x power 2n, that like this, x power minus 2n into x power minus 2n minus 1. We can add the powers.
Option A, sir.
Option A. Okay, option A is the right answer. Very good. So what happens here? When you add the powers, minus 2n b squared x into minus 4n minus 1. Very good. A is the correct answer. So is it clear for everybody?
Yes, sir.
So is it clear for everyone? Yeah, just a moment. Hello?
Yes, sir.
Yes, yeah. We'll move to the next one. Here in the next sum, they have said the motion of a particle along a straight line is described. X, okay. They given a motion as an equation. X is equal to 8 plus 12t minus t cube. Okay. Where x is in meter, t is in seconds. The retardation of the particle when its velocity becomes 0. What do you mean by retardation? Anyone? What is
Negative acceleration.
very good. Retardation is nothing but negative acceleration. It can be represented as minus a. Okay. So they're asking what will be the retardation of the particle when velocity becomes 0. When velocity is equal to 0, what will be the retardation R? That is minus A. Retardation value. That's what they asked. Do you have any idea? So which in this equation, okay. So which case does it support? Excuse me, ma. One student is just joining. Bernalini, welcome to the class. So which case does it support? X. What can we say about X? This X can
Dis-
be, yeah, yes. X can be
Distance,
distance, okay. It can be distance or
displacement,
displacement or position.
position.
Which will be apt for this equation? Is it a function of time? Yes, only no.
Yes, sir. Function of time, sir.
So which case is that one? Distance
Three, sir.
is it distance as a function of time, or displacement as a function of time, or position as a function of time? Which case? Case 1, displacement as a function of time. Am I right or not?
Yes, sir.
Yeah, okay. So now you have to find out the retardation. Okay, I'll tell you the concept. Okay, so they're asking what will be the retardation, that is minus A value, when velocity is equal to 0. First, you have to find out velocity. What is velocity? Dx by dt,
Dx
right?
by dt, sir.
Yeah, you find a value. Okay, and when you find out velocity, okay, you will get a value of yeah, find velocity value and assign that value to 0. Okay, then you find out time value, and okay, then you find out acceleration. What is acceleration?
dv by dt, sir.
Very good. Then find out this value. And what is retardation? Retardation is what? Minus acceleration, no, negative acceleration. So find this value, and you know, at last, okay, give a minus to it. That's all. Can you do this sum?
Yes, sir.
Yeah, I can give you 3 minutes or 5 minutes, you can take, no problem. Okay, just tell me the
Okay,
answer.
sir.
Yeah, right.
Sir. Sir, finished, sir. Sir,
Yes.
the option D, sir.
Option D. Your name?
Jayashree, sir.
Very good. So option D is the right answer. Is everybody getting it? Do you want me to solve the sum for you? Anyone? If you want me to solve the sum for you, I can solve it. Anybody? We have Darshini, Mrinalini, Nitish, Soumya. You're getting the answer, or do you want me to work it out for you? I can do that. Or we can move to the next problem. If you're getting the answer, we can move to the next problem, or else we will solve this problem and it can go. But kindly reply, okay? At least reply through chat.
So got the answer.
Okay, very good. So we'll move to the next one, right? So what about this question? They have said the position x of a particle. Okay, here they have said it is position x. Okay, with respect to time along x-axis given by x is equal to 9t squared minus t cube, where x is in meters and t in seconds. What will be the position of this particle? Okay, what will be the position of this particle when it achieves maximum speed along positive x direction? It is asked in 2007 and it's a good question actually. So do you understand this question? So they have given a position x, okay, in terms of an equation, and they're asking what will be the position of the particle when the particle, that is the particle, when the particle achieves maximum speed along x direction. So this is the question actually. What will be the position of the particle? This is given. This is the question. What will be the position of this particle when it achieves maximum speed along positive x direction? So do you understand what they are asking? So is it clear what they are asking?
Yes, sir.
Yeah. So when the position, what will be the position of the particle when it achieves maximum speed along the positive x direction? Just a moment. So yes. So do you get the idea how to do this sum? So they're saying as it is like it is obvious it is in a straight line. Okay, motion is along a straight line. Okay, and they are given the position as a equation. Okay, they're asking what will be the position of this particle when it achieves maximum speed along positive x direction. So what is the condition here that you have to find out? Okay, are you able to find out the condition? So they're asking what will be the position of this particle when it achieves the maximum speed. For example, let's say if you're traveling in a bike, okay, or a car, okay, in a straight line, okay. So let's say the speedometer, okay, the speedometer is like this, okay. The maximum speed, that what is the maximum speed in any vehicle? Maybe we'll have it as like, you know, it starts from 0, okay, 0, 10, 20, and this is the maximum speed. It is like 80 kilometer per hour. Okay, so this is the maximum speed that is in the speedometer of the car. Okay, speedometer of the car. So for instance, if you know, you have started the car here, okay, you have started the car here, you started at 0 kilometer per hour, okay, and after some time you'll reach like 40 kilometer per hour. You'll accelerate, and if the road is free, okay, if the road is free, it is a straight road, it is free, and you'll go at the highest speed. Okay, so you'll go at the highest speed. Actually, you'll try to go at the highest speed. So what is the highest speed here in this scenario?
Fast to the direction for a long time.
Excuse me, ma? I'm saying in this scenario, what is the maximum speed? We are traveling in a car, so we are traveling in a straight road. So, okay, so there's no traffic and everything. So we'll try to, we'll try to go at the highest speed. So what will be the maximum speed that we can go according to this speedometer of that car? So you start here, you start by 0 kilometer per hour, you accelerate and you go at 40 kilometer. After some time, after some acceleration, you'll reach 60 kilometer per hour. Am I right? How much further it can go? See, I said the speedometer is, from 0 to 80. Okay, so we have reached 60. So how much further you can go? How much further speed we can go?
Again 0, sir.
No, not again 0. Yeah, see, we started from 0. Okay, for example, if you are traveling in a straight road, okay, you have started the car, you started, your speedometer will be like this, okay, in this position. So after that it will be like this, 30, 40, okay, then maybe 60, 70. How much further we can go? After reaching 70, it will go to 80, right? The
Yes,
maximum
sir.
speed. Okay, so for say we have achieved a maximum speed here at this point, that is 80 kilometer per hour. Okay, then can we move further 80? This is the maximum speed in this speedometer of a car. You understand the example, no?
Yes, sir.
Okay, so we have achieved this 80 kilometer per hour here. Okay, so we are going to travel. There is a more distance to cover. Okay, so what will the speed here and all? After attaining this maximum speed, what will be the speed here in this position? This position?
81.
Not 80, 81. See, 80 is the maximum speed I said. See, in speedometer, if you have like 0, speedometer, no? In bike and car, there is speedometer. So it is 20 kilometer, 40. If there is only 80 kilometer as maximum speed, can you go beyond that?
No, sir.
Yeah, that's what happens here. So you have attained 80 kilometers here, okay, at this point. So, and the further positions like here, here, and here, what is the speed you will go? The same 80 meters only, no? That is 80 kilometer only, no?
Yes, sir.
So what happens here from here, from this point into the further point, that is to the further portions, what happened here?
Same 80 kilometer we are traveling, sir.
That is called as velocity. So velocity is what? 80
dx
kilometer
by
per hour.
dt.
No. Velocity is what? 80 kilometer per hour, right?
Yes, sir.
So we have achieved maximum velocity here. Okay. After achieving this maximum velocity here, and after achieving this maximum velocity here, the further positions from here, here, what do you observe? There is no change in velocity or not? Do you get
No
the
change
example?
in.
Is it clear, ma?
Yes, sir.
See, we are starting the car. We are slowly going from 0 to 20, 20 to 30, 40, 50, 60. And we have attained 80. We attained the maximum speed. After attaining the maximum speed, what happens? We'll go to 80 only. We cannot go beyond that.
Yes, sir.
So there is no change in velocity after attaining 80. Okay. No change in velocity means what? Acceleration is equal to, see, if there is no change in velocity, what happens to acceleration? Anyone?
Acceleration remains constant.
Acceleration remains constant. No. Who's this actually?
Darshini, sir.
Okay, Darshini, what is acceleration? Can you define? What is acceleration? Anyone? Anyone? What is acceleration?
Rate at which velocity changes with time, sir.
Okay, rate at which velocity changes with time. If there is no change in velocity, then what happens to acceleration? Acceleration is nothing but the change in velocity, right? There is no change in velocity. So what happens to acceleration? Acceleration 0. So you understand this? Jayashri?
Yes, sir.
So you understand this? What happens here?
No change in velocity, sir.
Yeah, no change in velocity. See, what will be the position of the particle when it achieves maximum speed along? So when the body achieves maximum speed, okay, let's say this achieves maximum speed here, then there will be no change in velocity. So when there is no change in velocity, okay, acceleration is equal to 0. That's what they are saying when they achieve maximum speed. When the body achieves maximum speed, there will be no change, no further change in velocity.
Sir, so here dv by dt equal to 0, sir.
Yeah, dv by dt is equal to 0. Very good. So acceleration is 0. So that is dv by dt is equal to 0. So you understand this is the condition they have given indirectly.
Yes, sir.
Okay, a moment, ma. Just a moment. So yes, dv by dt is equal to 0. That is good. Okay. A moment, ma. Hello.
Yes, sir.
Yeah. So dv by dt, that is acceleration is 0. Okay. So now what you have to do, you know that acceleration 0 that is given indirectly in this question. Okay, that we have found out. So you know what is x? X is equal to 9t squared minus t cube. Case 1. Okay, displacement as a function of time. So now find out velocity. What is velocity?
dx by dt, sir.
Dx by dt. Very good. So d by dt of, substitute this x here. So 9t squared minus t cube. So what happens here?
18t minus 3t
18t
square minus
minus
3t
yeah
3t square, sir.
3t squared. It is nothing but velocity, right?
Yes, sir.
Yeah. Now find out acceleration. Acceleration is equal to dv by dt. So in the place of
Equal
v,
to
yeah, in the place of v, 18t minus 3t squared. So what happens? I'll write it here. Yeah. So
18
what?
minus 60, sir.
18 minus 6t
60
is equal to acceleration,
is
right?
0.
Yeah,
Yes, sir.
very good. So now substitute a is equal to 0, the condition given in this question. So when 18 minus 60 is equal to 0, okay. So what happens? Take this 18 here. So minus 60 is equal to
T equal to 3
minus 18.
seconds, sir.
Yeah, very good. T is equal to 18 by 6, right? Yeah,
Yes,
so
sir.
T
3
is equal
seconds.
to 3. Yeah,
3 seconds.
yeah, T is equal to 3. So what happens here? So when I'll erase all this. So when acceleration is equal to 0, okay. So when acceleration, the given, the thing given in the question, when acceleration is equal to 0, time is equal to 3. Now you need position. Position equation that is given here. So substitute this t is equal to 3 in the position equation, that is x is equal to 9t squared minus t cube. So substitute this t value in here. So 9 into 3 squared minus 3 the whole cube. Okay.
Sir, option A, sir.
Option A, 54 meter. Okay, very good. Option A is the correct answer. Okay. So when acceleration is equal to 0, when the body achieves maximum speed, so when the body achieves maximum speed, acceleration is equal to 0. So when it achieves maximum speed, time becomes what? 3 seconds.
3
and
seconds.
and the position where it achieves maximum speed is 54
54 meter,
meter.
sir.
Very good. So do you guys get it? Is everybody getting it? So is everybody clear? Darshini, Jayashri, Mrinalini, Soumya,
I'm clear, sir.
you're clear. Okay, okay. What about Soumya, Darshini? Darshini, are you clear?
Yes, sir.
Okay. So yes. So this question, can you do this by yourself?
Yes, sir.
Yeah. Do this and tell me. A particle moves along the straight line OX at a time t. The distance that is given by x. How long would the particle travel? Here there is a slight mistake in this question. So how long, you can, for how long means we can say, we can misinterpret this as time also. For how long it will take means, if that is given in seconds, then you have to find time. Okay, so how long? Okay, here it represents distance. How long would the particle travel before coming to rest? Okay, so be careful with that. A particle moves along a straight line OX at a distance that at a time t in x seconds. Okay, and the distance x of particle from O. Okay, sir.
Sir,
So you got the answer?
Sir,
Yes.
sir, I think option C, sir.
Option C. Your good name?
Jayashree, sir.
Okay, ma. We'll just see. See, they have given x. Okay. So as I said, x can be position, displacement. Okay. X can be position, displacement, then distance. Okay. They have given x as a equation, that is 40 plus 12t minus t cube. They are asking how long would the particle travel before coming to rest. Okay. So what you have to understand is a particle has started a motion in a straight line. In a straight line, the particle has started. It has traveled a distance, right? It has traveled some distance, okay, and it has come to rest. That's what the question says. It has come. Eventually, it has come to rest. They are asking how long the particle traveled before coming to rest. So how long they are asking? Basically, they are asking the distance. Okay. So clear till now?
Yes, sir.
Okay. So they're asking how long the particle have traveled before coming to rest. At rest, what happens, ma?
Velocity will be 0, sir.
Very good. So that is what they have given here. From this point, from rest, okay, the condition they have given indirectly is velocity is equal to 0. Okay. So now you have to do, now you have to find out velocity. Velocity is nothing but dx by dt. So d by dt of 40, x is here, okay, 40 plus 12t minus t cube. So what happens here? This becomes 0.
Yes, sir. 12 minus 3t square, sir.
12 minus 3t squared, very good, is equal to what? Velocity.
Yes, sir.
And velocity is 0 according to this condition. Okay. So when velocity is equal to 0, 12 minus 3t squared is equal
Why
to 0.
did 2 seconds, sir?
2 seconds. Okay, minus 3t squared is equal to minus 12. This one cancelled. So t squared is equal to 12 minus 3. So this will go 4 times. So t squared is equal to 4. T is equal to 2. Very good. So when velocity at this point, how long would that particle travel before coming to rest? So at rest, okay, at this point at rest, velocity is equal to 0. T is equal to what? 2 seconds. That you have found out. Okay. So as I said, you know this x. Okay. So x can have values of what? X can be defined as position, displacement, and distance. What they are,
Distance.
yeah, what they are asking? They are asking distance only. Okay.
Yes, sir.
So now I'm going to write this x as distance, that is 40 plus 12t minus t cube. Now substitute t is equal to 2 in that equation. Substitute t is equal to 2 in this equation. So what happens? X is equal to 40 plus 12 into 2 minus 2 cube. So this becomes 40 plus 24, right? 12 into 2, 24 minus 8.
Yes, sir.
So what happens? I think 64 minus 8. Right? So this goes to 64 minus 8. So what is the answer?
56.
Yes, 56 the right answer. 56 the distance here. 56 meters the distance from here to here at rest. While attaining the rest position, okay, the distance traveled is 56 meter. Velocity is equal to 0. Time is equal to 2 seconds. So you understand this question?
Yes, sir.
Okay. So yes, so we can go with uniform acceleration, but since time is not sufficient today, we have to do that tomorrow. Okay, tomorrow we'll see the concept of uniform acceleration.